Okay, we're going to go ahead and start on match pairs. 9.3 in your book. In your notes, it's 9.4, but in your book, I believe it's 9.3. um, I don't believe we'll have time to go over the final section in your homework, which would be our final part over here in the notes, chapter page 9 and 10. We'll just do a little bit best we can. And I don't think I'm going to cover the very end of the section on chapter 10. So, I mean, we could do it, but everything does the same, but I'm just going to try to get you guys a quick hitter video with this one. And then we'll move on to chapter 10 as we're getting closer to the end of the semester. So now we will discuss the methods for interest for match pairs, dependent samples. A lot of times these are before and afters, not always, but a lot of times they are. For match pairs of sample values, calculate the difference between the two values. Then we use the sample difference to test claims about the population difference and construct confidence intervals of these population differences. So the good news is nothing's going to change. Everything's going to be just like we've been going over in chapters 8 and the beginning of chapter 9. However, we're going to take a chapter 8 problem and we're going to turn it into, we're going to take a chapter 9 problem with 2 samples and we're going to turn it into 1 sample by subtracting the samples and getting a new set of data. Okay. So a couple things, the sample data are dependent. We call them match pairs. That's why a lot of times it's a before and after. Normally it's talking about the same sample group. The samples are random and either number of match pairs is large and is greater than 30, or the pairs values have differences that follow normally approximately normal distribution in the population. So pretty much standard stuff for us. Now this is the mean difference. Okay, so that's going to be very important, especially in the null. The mean value of the differences D in the population of all matched pairs. D bar is the mean value of differences. So mu D is the parameter that we're going to be discussing or testing. And D bar is the sample mean that we're going to be using. Standard deviation sub D is the standard deviation from our new differences. And then the number of pairs of data, okay? So something to note, all of our hypothesis tests for these will always look like mu D is equal to 0. So the null is saying that there doesn't appear to be a big difference. And the alternate hypothesis is saying that the difference is less than 0, the difference is greater than 0, and the difference is not equal to 0. So it also depends sometimes on how you subtract, if you get positives or negatives. So I'm going to kind of discuss that a little bit, but you normally want to be a little bit consistent in how you do it. I'm probably always going to do top data minus bottom data, but if you want to be like, I'm always going to do before minus after or after minus before, just be consistent what you do. I think the best thing for us is to get into one instead of talking a lot more about it. We're going to use the calculator pretty much for this problem as well. Now we could find the test statistic by scratch. Maybe I'll do that for the first one. But I just want you guys to really see that you can take match pairs and turn them into 1 sample instead of having to work with 2 samples. Okay. You can simply use the same method as a single sample hypothesis test for means with sigma unknown. So this is something we've already done. So that's why here we have stat test t-test. We've already done this, okay? And then it says set mu 0 equal to 0 or mu naught, okay? So below is the data. So let's look at this. It says below is the data for 5 actual low temperatures and the low temperatures that were predicted for those 5 days earlier. Is there sufficient evidence to conclude the mean difference is not 0, meaning that the forecast is out? Because if the mean difference is kind of close to 0, then doesn't that mean whatever he forecasted is kind of what turned out to happen? So that means that he or she are doing their job, right? So what we're going to do is we're just going to do top minus bottom, so you could just say top minus, bottom. And again, there's a lot of ways to do this, okay? You could do bottom minus top. You could say, I'm always going to do before and after, or after and before, but you got to kind of be consistent. In the homework, it might be a little annoying because you do it one way. That's when you might want to start thinking about, how they asked the question, how they phrased it. Those are things you might want to look into. So the first thing we need to do is we need to subtract all of these numbers. So I'm going to do 54 minus 56. That's going to be -2. I'm going to do 54 minus 57. That's going to be -3. I'm going to do 55 minus this. This will be -4. This will be 4, and this will be 0. Okay. So then if we were to add all these up, this would be the common difference, or not the common difference. That's a different class. Sorry, guys. This would be the difference, the sum of the difference. So we'd have -2, -3. So it'd be -5. And what d bar is d bar is -5 divided by the number of pairs. Well, there's 5 pairs, so we get -1. So we technically have our d bar now. We have -1. Okay. Let's see here. Oops. So I'm going to go through and do my same thing that I've been doing all along. Okay. So I'm going to say that mu d, the claim, let me see, it says temperatures differences are normally distributed. Is there sufficient evidence to conclude the mean differences is not 0? So I'm going to say the mean difference is not 0. And then I'm going to say the mean difference is 0. Okay. So then step 2, you guys should know by now. That means that we're going to do the null. Let me make this a little bigger so I can write nicer. I don't know if it'll help. My writing's not so good. So we're going to do the null, and the null will always be mu d equals 0, and the alternate will always be that mu d is either less than equal to 0 or less than 0, greater than 0, or not equal to 0. So we're going to do not equal to 0. And then we know step 3 that alpha is worth, let's see here. I think alpha is, they say it up here. 0.05 significance level, so 0.05. So we have a two-tail test. Okay, so we're going to compute the test statistic. So the thing is we've kind of hopefully been getting used to using our calculator. So we know that our step 4 is going to be, since we're working with means, we're going to be finding a t. So I'm going to take out my calculator and I'm going to do what the notes say. The notes say if we want, we can just go stat test t-test. Now notice it doesn't say 2 prop or 2 t-test or 2 sample. Well, that's because we just took 2 samples and converted them into 1. So what I'm going to do is I'm going to go stat test t-test. Should be the number 2 one. And I'm going to use stats. Now it asks you for mu d, right? Or mu naught. So they say mu naught right here equals 0. Then they want to know x bar. Well, we don't have an x bar, but we have d bar. And d bar is x bar for this new sample. So we know that it's -1. The standard deviation. Well, we did not find that. So what I got to do is I'm going to go back out of here, go stat, edit, and I'm going to put this list in. So I'm going to do -2, -3, -4, 4, and 0. And I'm going to quit, and then I'm going to go stat calc, and I'm going to get my standard deviation. My standard deviation is 3.1622. So I'm just going to use 3.16, I guess, okay? So we know that D is equal to that, and we now know that standard deviation is worth, let's say, 3.16, okay, from our calculator, all right? So now I'm going to go back into stat test. Now I can finish the problem, t-test. I have 3.16, and it actually has done it for me now. It did 3.162222. It plugged it in for me. My n was equal to 5. And we're doing a not equals to, and then I calculate, and I get t equals negative, negative 0.7076, I guess, if you want to go 4 decimals. So we get negative 0.7076. You could do, something close to that. So I'm feeling pretty bad right now because I'm pretty sure we're going to fail to reject the null. because a t-value of negative 0.7, that still leaves a lot of probability to the left or to the right of it, whatever we're dealing with. So I'm going to take my p-value. Oh, they already tell us, don't they? So right here, we take our drawing. And again, I'm just doing this. I already know the answer, but I'm just trying to keep grounded and show that I still can do what I need to do. So now my p-value is the addition of these two. So they tell me that I get a p-value of 0.518-ish. So they get a p-value, and that means that if I were to cut that in half, there's about 0.25 and some change here, 0.256 and 0.256 or something over here. So my two p-values are about 0.25, right? So that's my p-value. So we know the p-value is a pretty big number, which we were kind of sure because this is not a very large t-value, positive or negative. So this was my step 5, okay? And we say, since 0.518 is greater than alpha equals 0.05, we fail to reject the null. So our conclusion is there is insufficient evidence to support the claim that, and then let's see what the claim was. Is there sufficient evidence to conclude the mean difference is not 0? To claim that the mean difference is not 0. We cannot support that, okay? So we can't say that it is inaccurate. So it is possible that the mean difference is actually 0, which means that they are doing a pretty good job of reporting the weather, okay? Okay, so let's try one more. So it says researchers collect data on a number of hospital admissions resulting from motor vehicle crashes, and results are given below for Friday the 6th, on Friday the 6th of the month, and Friday the following 13th on the same month. Test the claim that Friday the 13th is unlucky, meaning there's a higher average for crashes. Okay, so the average on Friday the 13th is larger than the average on Friday the 6th. Okay, so once again, I'm just going to do, I guess we could just do, we could do top minus bottom again, and I would get -4, -6, -3, 1, -1, -7. So we're going to get a bunch of negatives. Okay, so let's see here. If we did top minus bottom, is that what I did? I want to keep it consistent. Did I do top minus bottom here? Yeah, so let's do top minus bottom again. So we got to be a little bit careful because just so you guys know, we're going to get mu d is equal, oops, not mu d, sorry about that. We're going to get equals d, which is, let's see here, -10, -14, -21, is that -20? So let me just put it in my calculator so we can just go stat, edit, -4, -6, -3, 1, -1, -7. 1, 2, 3, 4, 5, 6, 6 of them. So we go quit, then we go stat calc. And it tells me that my X bar is 3.3. So I'm just going to skip D and go straight to D bar. I know is -3.33 bar. I guess I could do this. Okay. You know what? I'm going to round it off to, let's go 3 decimal places. Okay. So that'll be our D bar, okay? So we got to come over here. So our D bar is that. Let me clean this up a little. So we're going to go over here. We're going to kind of get rid of this. And we're going to go step one. We know is the claim and the opposite. And that means that mu D. Now, if we're getting negatives, okay, if we're getting negatives, that means that we're going to be working on the left side of the graph. So that means that the mean difference is less than 0. And I'm just telling you guys from this formula up here. So if we're working with this formula right here, if D bar, if D bar is negative, right? So D bar minus the mean difference, which is always 0, you're going to have a negative over a positive. So you're going to always have negative numbers in terms of your t values. So that means that if you do it this way, you should do a left tail test for a negative when you get negatives, and right tail test depending on what they're saying. This one, it didn't matter because this was just different. They just cared whether it was different. They didn't care whether the difference was bigger or smaller than 0. They just cared that it was different. This one, they want to actually know if there's something increasing on Friday the 13th. So we're going to do the mean difference is less than 0. So if the mean difference is less than 0, that means when you take a bigger number, like 13, minus a smaller number, you'll always get a negative. If you had done it the other way, you would do the same exact problem, but all your numbers would have been positive, and you would have got 3.333 bar, but then your mean difference would have had to be greater than 0, because you're trying to test the claim that Friday the 13th has more accidents. And either way you look at it, you could still do it, but you just got to adjust, okay? And then the mean difference is less than or equal to 0. And then this one would be, and then the mean difference is greater than or equal to 0. So then the null and the opposite. So this would be mu D equals 0, and this would be mu D, why do I keep doing that? Mu D less than 0. So then step 3, we know alpha is going to be worth, what do they say? I don't think they actually say alpha in the problem, unless I'm missing it. Let me scroll out a little bit. Research collected from higher averages. Assume the normal population Friday the 13th. Compute statistic p-value. So they don't actually say, so I'm going to use 95%. That's pretty much our go-to if they don't say. So we're going to say alpha is 0.05. And hopefully that is okay. Yeah, let's go with 0.05 because they didn't mention. Remember I told you guys that when you're doing confidence intervals, 95% is the go-to. When you're doing hypothesis tests and they don't say, 5% is the standard significance level. And this is a left tail test. Okay. Now, if you were doing it the other way, you would be doing a right tail test. If you had done bottom minus top, okay, you would be doing a right tail test because you would have got all positive numbers. So it says compute the test statistics. So this will be our step 4. So I'm going to do my calculator again. I'm going to do t-test. Okay, so then t equals. So let's go stat test t-test. Now I already have the data entered in, so I'm just going to use that. And this time I'm doing less than. So I get negative 2.7 because I'm doing a negative. So this is negative 2.712, I guess, if you want to round off. Okay, some of you would get a positive if you were doing the right tail. Okay, which is still acceptable. You'll still arrive at the same conclusion as me. Okay, so we get that, determine our p-value. But so this is negative right here. So we know this is p-value on the calculator says 0.021. Okay, so p-value equals 0.021. Okay, so now let's go to statistical decision and justify. So this is my 5, this is my 6. And we say since our p-value 0.021 is less than or equal to 0.05 equals alpha, we reject the null and accept the alternate hypothesis. So we say there is sufficient, or we could also say, again, you don't have to get fancy, there is enough evidence, there is sufficient evidence to support the claim that the mean difference in accidents is greater. Oops. So let's see here. We're saying the mean difference is less than 0. So mean difference in accidents is less on the 6th, or was it at car accidents? Yeah. Versus the 13th. Okay. So that, and again, if you guys had done it the other way, you would have said that if you had gotten a p-value, you would have still got 0.021, but you would have got t is equal to positive 2.712. And then you would have said that this is greater than 0. The mean difference is greater than 0 because you would have been saying bottom minus top. So all your numbers would say you'd have more means on Friday the 13th. What I'm saying is I have less mean or I have less average accidents on the 6th versus the 13th. You would be saying you have more accidents on the 13th versus the 6th. We're saying the same thing, kind of like I told you guys a long time ago, the beginning of the year, the difference between greater than and less than is depending on perspective. I could say, I am taller than you. And then you could say, no, 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 you are shorter than I am. Well, we're both saying that I'm taller than you are, but you're just saying it from a different perspective. So that could get a little bit hectic on this problem. And I think in one of the homework problems, they want it a certain way. So you got to do top minus bottom or bottom minus top. I can't remember. You'll have to mess with it a little bit, but keep that in mind when you're doing it. Don't feel bad if you have the exact same numbers as them, but they have the negative and you have the positive or vice versa. Okay. Let me see here. So I think we could just do one of these and then we can call it a day. So I started this one again, and I just want you guys to know we are always looking for this 0 when you're dealing with 2 samples, okay? So we're gonna build a confidence interval based on our new data. So we're gonna, once again, just like here, we did top minus bottom. I'm gonna do top minus bottom again. So I got 2, 2, 0, 0, -3, okay? And that gave me a mean difference of 1. I'm sorry, a difference of 1. And then when you find the mean of that, you get 1/5 or 0.2. Okay, so they want me to construct a confidence interval. So all I'm going to go and do is I'm going to follow the instructions. It says stat test t interval. So I'm going to do t interval. And let's see what we get. So I'm going to go to test, stat test t interval. And then, oops, you know what I forgot? We got to do our data, okay? So, well, maybe they don't even ask for it. I'll just enter it in anyway. Stat, edit. Let's do a new list. Okay, so let's enter in 2, 2, 0, 0, -3. Okay, so now we go into stat test t-test. Nope, sorry about that, you guys. Stat test t interval, because we're doing intervals. And then I have data from list 1. And what level of confidence do they want? 95% confidence. Okay. So they give me -2.345, comma, 2.748, I guess, if you round off. And they say our X bar is 0.2. and our standard deviation is 2. All right, so it says, use the confidence interval to test whether there exists a mean difference. Well, is 0 in the interval? Well, if 0 is in the interval, it says you are always looking to see if 0 is in the confidence interval to determine if the match groups differ from one another. If 0 is in the interval, that means that mu1 minus mu2 equals 0, right? Because they're the same. That means that the null is possible, okay? So use confidence interval to test whether there exists a mean difference. Because 0 is in the interval, I'm not going to say there appears to be a significant difference. So since 0 is in the confidence interval, there does not appear to be a significant difference in means, okay? Now, once again, this is because we were using matched pairs, right? We were able to do that. I think you guys could go through and do the same thing with this one. Let me know if you need any help. I didn't want to make this video too long. This was just the final video from chapter 9. The end of your notes, this last page here, we're not going to do. I'm just going to try to conserve a little time and pick my battles here and there. So let me know if you guys need a little help. Other than that, that'll be the end of this video.